Hello all. Today we will discuss about the thermal performance and related numericals and formula for assessing the thermal uh, performance of envelope, a building envelope. So first there are three levels: element level, component level and assembly level. These three level is considered for the study of the building envelope. So first, element level. At this level, material constituents and its behavior towards thermal resistance and heat flow is checked, and this comes under the thermal conductivity. If we are talking about thermal conductivity, then it's a element level. And if you talk about component level, what will be the thermal behavior of particular components like brick and blocks? So that tell majorly about the behavior of thermal performance. And if we want to know at assembly level, like a wall made of window, wall, and too many layers of insulating material and including plaster. So these different components form assembly, and it tells the actual behavior of the thermal performance of a particular uh, building and particular wall. So in component level, thermal transmittance counts, and thermal transmittance is U value, and that's why we take U value when we buy any material for wall. And for thermal efficiency and thermal performance, we check the U value of that particular part. Now, if we talk about assembly level insulations material, so those material are resistive and reflective and capacitive in nature. So capacitive insulation is our material which keeps thermal energy for a long time, and it is also known as thermal mass. So when we talk about the thermal mass, it's actually a capacitive insulation which is having the that capacity to hold that heat for a long period. And now quickly we will discuss about the mode of heat transfer. As you already know, conduction, convection and radiation is the main form of heat transfer in a building. So now quickly we will get into the uh, formula which calculate the heat flow. So for conduction heat flow, QC is equal to A into U into delta T. Here U is equal to thermal transmittance value, and QC here is conduction heat flow rate in watt, and A is the area of surface and delta T is the temperature difference. And now convection heat flow is equal to 1300 into V into delta T. So here this convection heat flow when we used to do ventilation through air conditioning and forced mechanism, that count in convection. So 1300 here we take the specific heat of air. V is equal to ventilation rate in cubic meter per second, and delta T is a temperature difference. So, and this particular formula comes in calculation of uh, ventilation rate and in air conditioning problem. So this formula phi is equal to A into U into T1 minus T2 is the actual heat uh, for heat flow calculation. Like phi is the heat transfer in watt, U is the thermal transmittance here, and T1 is the temperature on one side of the structure, and T2 is the other side temperature, and A is the area in square meter. So if you know these quantity, we can calculate the heat transfer in a wall. And if we talk about the U value of wall, so U value of wall is equal to thermal conductivity by thickness of wall. We divide thermal conductivity by thickness of wall. So U value of wall, if thickness of wall is greater, U value will be the less, and if thickness of wall will be the minimum, U value of wall will be the maximum. So U value depends upon the thickness of wall. and thermal transmittance vary according to the thickness of wall. But I can say here, like thermal conductivity, it does not depend on uh, total thickness of that component or that wall. It depends per square meter of thickness or per thickness of that material constraints. So thermal transmittance here is watt per square meter Kelvin. So this becomes the unit. And again, R value of wall is equal to thickness of material by conductivity. So R value is the inversely proportional here. So that's why thickness of material is divided by conductivity. So if conductivity is the less, then R value of wall will be maximum. So resistance of wall will be maximum. And U value of composite wall, we can say 1 by R value. And the formula is square meter Kelvin per watt. So, and if we calculate total U value of that composite wall, so first we have to calculate sum of R values. Sigma R here is equal to 1 by HO plus R1 plus R2 plus R3 plus 1 by HI. So HO, HI is film surface here, film surface conductance coefficients, and outdoor air film R is equal to 1 by HO, and indoor air film uh, here is 1 by HI. So these we take for the air film as a air film coefficient. Then we calculate the true resistance and R value of the building. Sum of these resistance value for each layer of a construction. R1, R2, R3 is the resistance value for each layer of construction. So the thermal conductance here becomes U is equal to 1 by sigma R. So whenever we are calculating thermal conductance and U value of that particular wall or particular composite wall, we have to calculate first R value of each R value, total R value, then we use this formula. So now also this formula gives the thermal behavior and heat flow. T solar air is equal to T outside temperature plus A into I by HO. So this solar air temperature is the outside exterior temperature, and the surface gets inside surface gets it from the exterior surface. So this is the exterior temperature, and generally sometime this temperature is the total heat transfer into the building. So we calculate this solar air temperature by this formula. Outside temperature in degree centigrade here, T out, A is equal to absorptivity of the surface, and A is the absorptivity. Then I is equal to global solar irradiance, and in numericals this is sometime given, and it is watt per square meter. Then HO, heat transfer coefficient for radiation and convection, watt per square meter Kelvin. So heat transfer coefficient for radiation and convection. So this is HO, this is given as heat transfer coefficient for radiation and convection. So equally for radiation and convection, we take this HO, heat transfer, and then this formula becomes the calculating the total solar air temperature of by exterior surface to interior surface of the uh, that particular wall and that particular building. So these formula here